Okay, Mythical Man-Month. Why is this required book for this text? This is written by Fred Brooks back in 1975. Is still one of the 2 or 3 most important books about software engineering ever written. Not just because he got there first, but he covered so much ground. I have been consulting and lecturing and writing on software engineering, and specifically on project failure and success, really since the mid-90s. And every time I have thought that I had some brand new insight, I would go back and look at Mythical Man-Month, and sure enough, there somewhere he'd have a sentence, and he'd have it right there. Fred Brooks was in charge of developing the OS 360 operating system, which, by the way, is the first operating system I ever used. Back when I took 142, it was called 132 back then. We started off doing machine and assembly language in an IBM 360 mainframe. And so you have been spared the joys of things like JCL. Anyway, why it's important is because, as I note here, it's hard to quantify software project failure cost because a lot of companies and government organizations do their best to hide it. But it's easily $100 billion a year. There are project after project that either fail, they're abandoned entirely, or they are significantly over budget, over schedule, and do not deliver the benefits that were originally intended. Projects fail all the time. The biggest active failing project I have ever worked on, not worked on as I was one of the team members, but where I was called in, was a big re-engineering project at a Fortune 50 company. They were trying to replace a number of existing systems with a unified end-to-end system. The project was originally supposed to take 2 years and cost $180 million. By the time they called me in, it had been 4 years. They had spent $500 million, as I think I mentioned last week. They did not have any code in production. They spent 4 years, it spent $500 million, they had 0 code in production. Furthermore, I had a team of 3 people with me. We spent 3 months because they wanted to know, what's it going to take to get this into production? And we spent 3 months, and our report is, you're going to have to go back and redo a lot of stuff. In this particular project, they never had a chief architect, they never had a QA department, and yet they spent $500 million. They didn't like my report. That's a whole other story, which I'll tell at some point. I'll save that for another thing. Anyway, I mentioned here, I testified before Congress 3 times, which my standard line there is just goes to show you any damn fool can testify before Congress. And a lot of us have. That's a whole other story I'll tell sometime. I got sucked into that. But I was talking about project failure, and I cited Mythical Man-Month and said you could consider it to be like the Bible of information technology because, as I say there, it is universally known, it is often quoted, it is occasionally read, and it is seldom heeded. If you go out in the places that you work now, or places you go to work, and you talk about the Mythical Man-Month, everyone will nod there, oh yeah, I've heard that. Do you have a copy? Oh no, I don't have a copy. Have you ever actually read it? No. Do you know what it says? Well, it says don't add people to a late project. Do you ever add people to a late project? Oh yeah. My first experience with this, I was back in 1995, my first consulting job, went into ARIC, Aeronautical Radio Incorporated. They were building the network management software for the Iridium satellite phone system. Motorola was a prime contractor, they were a subcontractor. They were supposed to be using object-oriented technology. no one in their development team really knew object-oriented programming. So they'd had an absolutely disastrous design review. And they were looking for a chief architect, and I applied. Pages just finally closed. Dead startup. Anyway, and I mentioned that I'd just written this book, Pitfalls of Object-Oriented Development. And the department, the vice president over the division in Newport Beach went out and got my book and read it and said, oh my gosh, these are all the things we're doing wrong. So they actually wanted me to come in as a consultant, which was really nice. My annual salary sort of doubled overnight. And one of the things I quickly learned, besides the fact that they had no architecture, they had 4 subsystem diagrams, and I tried to match them, and they did not connect. They were building these 4 subsystems, but there was no consistent interface among them. Anyway, but I saw some just classic project managers, and I went to the division head and said, would you give me a budget and let me buy copies of the Mythical Man-Month? He said, sure, that sounds great. So went out and bought 30 copies, gave them to everyone, from the head of the division, all the layers of management, all the developers, everything else. And said, as part of my work in here, I want you all to read this. And about 6 to 8 weeks later, went back through and could not find a single person who could crack the book open. That's why I have you read these books now, and that's why I stress, hold on to your books. You finish this class, you will know more about the nature of IT projects and their success and failure factors than 90% of the people you work with. And you'll walk around saying, it's a bit like, the movie They Live, with the glasses where you can see the aliens suddenly. That's what IT projects start looking like. You go into places and you say, oh my gosh, they're doing this, they're doing that, they're doing this. It's a good safety protection mechanism. Okay, chapter 1, and by the way, I'll assume you have read this, so I'm just going to cover stuff very lightly and then ask for feedback and question. He has sort of a 2x2 complexity. How many of you have written a program for yourselves? Just a simple program. Okay, that's his simplest type. How many of you have written or contributed to a program for commercial release? Okay, what's the difference between those two? How much more care do you have to take for commercial release? Thoughts, comments? Infinite, yeah. It's a lot more work if you're going to put it out there in the market, isn't it? Okay, how many have written software libraries or tools or whatever for other developers to use? Okay, how many of you have written software tools for other people to use that are then sold commercially? That's his most complex thing. Now, he has operating systems in there. Most of us don't write operating systems. Most of us, if we do that at all, it's going to be here's a library or a set of routines, or we're doing microservices nowadays, whatever you're doing. So he's got this 2x2 diagram and says, here's the program you write for yourself. Here's the commercial program. And he basically says that's 3 times more difficult. Here's what he calls a system. So this is like an operating system, API, library, that you're doing for yourself. He says this is 3 times more difficult. And here's a commercial operating system, set of libraries, whatever. And basically that's 9 times more difficult. So the difficulty is in there. I, for a couple of years, used to write several of the manuals. Borland, how many of you ever heard of Borland? Okay. They were innovative back 30 years ago in first Pascal and then C compilers for personal computers. Because they were small and blindingly fast. Anders Heilsberg, who was one who designed the compilers, then went on to Microsoft And he's been working under languages there for quite some time. Did C# there. Anyway, and because of writing I had done on programming, I was contacted by Borland, said, we'd like you to do a tutorial on Pascal, then can you do our user manual for Turbo Pascal, then can you do our user manual for Turbo C and a reference manual and so on. Because I could write fast, and I was a programmer. So I knew what I was writing about. Philippe Kahn, who was the founder of Borland, once in talking to me, said, he says, never choose development tools as a software business. He said, developers are developers do not forgive an error in a compiler. Which I'm sure all of you can immediately identify with. Like, yeah, no, I wouldn't forgive that either. So when you're doing operating system / language / library stuff for commercial use, it's the toughest, it's the most demanding, because people will be absolutely furious to find bugs in there. You would think. Then again, you have Microsoft Windows. What are, in your experience, or your observations, some other things, other types of software that are difficult or complex, or things that add to making software difficult to develop and maintain? Any thoughts? Yes?
Turnover in personnel.
Oh yeah, and we'll talk about that. That's a big issue. Other thoughts?
Changing their testing strategy. I worked in a place that kept on changing their automated testing kind of strategy that I was working on.
Yep.
That slowed things down quite a bit.
How about within the yes?
I was just going to say, with a big project, sometimes it's hard to find the flow so that you can be consistent with what someone did in the past.
Yes, and we will actually talk a lot about that. Maintenance. 60% of software budget is spent on maintenance. There's most of the money that you spend on a software project is after its initial 1.0 ship. And so if you lose that knowledge, it gets back to the turnover issue. If you lose that knowledge, it becomes a problem. Yeah.
Say from experience, poor documentation.
Poor documentation, yeah, and poor code, yes.
Features that can't be dropped.
Features that can't be dropped. Oh, backwards compatibility. We'll talk later on. I wrote an article for Windows Magazine in 1996 called Windows Forever and Ever, where I said, in 1996, I said, I'm willing to bet 30 years from now, Windows will still be the dominant desktop operating system. So that was, or 20 years from now. Let's see, yeah, that was 96. So guess what? We're almost to 2020, only a few years away from that. Windows is still 80% of the desktop worldwide. Now we have whole other categories. We have mobile devices and so on and so forth. But stuff gets entrenched. And Microsoft has dealt with this issue where they have had to maintain backwards compatibilities. And every time they try to move away from it, there was such an outcry because of people who depend upon the older features in software. Yeah.
You took it a really good direction. I was actually also talking about a new project where just like, well, we're behind on schedule. Like, well, we can't drop these features.
Oh, that.
How do we make it?
Yes. Thank you. That is actually, and of course, you will hear this mantra from me. I think I already said it last week. Only way to gain time on the schedule is to drop features. And it's very hard to get managers, and especially marketing types, to accept that. It's why you have one of the dictums you will hear me quote time and again from my close friend and colleague Bruce Henderson is start out stupid and work up from there. What do you guys like about programming? Why are you stuck with this? Yes.
The feeling of overcoming the problem.
Yes, feeling of overcoming the problem. Other reasons you like programming? Yes.
It's very easy to be creative.
It is.
Around little worlds.
What else?
Well, you can kind of do stuff that maybe you don't even fully understand, like machine learning and all that.
Oh, yeah.
You know how it works, but it works.
It's like, yeah, let's just let this run for a while and see what happens. Yes.
Creating unique things.
I'm sorry, creating
Creating unique things.
creating unique things, yes.
When you mastered certain like design patterns and stuff, and you start handling
Start building.
more certain technologies, and you're able to build things really quick, it makes you feel like a wizard.
It does, and that actually, the wizard thing is a good thing. It's something, that's an analogy that Brooks uses, and it's one I've used. Something over in Quora. Someone had the question is, I'm trying to remember how it was cast, but it basically is, what do most people don't understand about software engineering? My answer was, it's magic. It's the closest thing to magic that humans do. You type incantations, and you control machines. You bring gorgeous pictures to life and create virtual worlds. It is the closest thing to magic that we have as humans. Yes, you have it.
I was gonna say it feels good when people tell you that they use your stuff.
Oh yeah, I told you I did Sundog. I still get email. That's over 30. It's almost 35 years ago. I still get email from people who go, oh yeah, that was great. I almost won 7th grade. Seriously, I had someone send me that email. I felt sort of torn. You had it, didn't you?
I was going to say, abstract design patterns or solutions. I like when you learn a new one, it's mind-blowing, and you're just like, that is genius. It's so simple. And it's just cool to have that moment kind of over and over again.
I was doing, I had been out doing real world software engineering product development when the very first Gang of 4 design patterns came out. When it came out, I went through it. For about half of the design patterns, I thought, oh yeah, we did that. For the other half, it's like, oh, I could have used this. This would have been so good. Yes?
You can always learn something new.
I'm sorry?
You can always learn something new.
You can always learn something new. A lot of my kids work in IT. And as they've gone into it, I've told them, here's the good and the bad part. I say, you will be learning for the rest of your life. Good part is people will pay you to learn that. And you will become more valuable as a result. I have a son who works for a company up at Point. Actually, I have 3 kids who work up at Point now. I have a son who works up there as a software administrator. He's in the middle of getting his certification in AWS. No, not AWS, Azure. And he's enjoying it, and the company's encouraging him to do it, and he says, I'm going to get a 10K bump in salary as soon as I get the certification. And I said, yeah, and once that's on your resume, I said, you can find a job at just about anywhere. So I have hundreds of books. I still have to learn new stuff because I get dragged onto cases that use technologies I haven't used before. But I've been trained through 40 plus years of this, how to learn something new. Yeah.
I like that you speak and it creates or it works. I imagine it feels similar to what commanding elements would be like.
Yeah. It's cool. Now, of course, the offers is when you're beating your head against the wall and you figure, well, you just can't get it to work. Yes. It's like, yeah.
I just feel a satisfaction in knowing that like something I built is always working.
Yeah.
Even though I'm not, like I go to bed at night and I know that stuff I built is still running.
Tony Gibson, who founded OSG, where I worked for 3 years as CTO and have done other consulting work for them in the years since. His first programming job was doing this dedicated system to basically manage a railroad train yard. It was done, I think it was done on a PC. He did all the coding and so on. And 20 years after he wrote it, it was still being used to run the rail yard. Now, they may well have wanted to upgrade it, but no one had managed to do it so far. So, it's, basically, you guys have said the stuff that's in there. It's just fun creating software, making stuff work, and having people use the stuff that you've developed. Now, what are the problems with programming? What are the things you like least about programming? Yes?
The computer.
The computer. The stupid computer. Yes?
The stupid me.
Stupid me. Yes?
Debugging.
Debugging. And as Brooks says, we expect debugging to sort of get faster as we get closer to finishing the program. Instead, it tends to go slower because all the hardest bugs get left. Yes?
Depending on other people's programs.
Oh yeah. Okay. Oh, this is one of my maxims. The overall quality of a complex system has as an upper bound the lowest quality of any component of that system. Now, you can twist that a little because if the component isn't used much or if it isn't terribly important, it becomes less of an issue. But generally speaking, yes. Yeah.
Adapting your program is the thing you depend on. This kind of things you depend on change. Like when you're working with open source things, it's
Suddenly, bam, it doesn't work
yeah,
anymore.
suddenly, oh, your program won't run anymore. What changed, right?
Testing for hours and then you release the still bugs.
Oh yeah, yeah. That's sort of Sundog. I would have sworn our 1.0 Sundog was just rock solid. I mean, this was on 64K of RAM on an Apple II. I knew the memory map. I knew every single byte in there. You know, I had done 90% of the coding. It was all in my head. We went to the West Coast Computer Fair, had a booth, put it up, and in 4 days, people coming in and using the program in the booth found 30 bugs. I had a notebook where I just kept writing this thing. Now, the good news is that it only took me 3 weeks after the trade show to fix those 30 bugs, and I only had one other bug ever reported in that version, which people like because it allowed them to cheat. Basically, you could go into bars to buy stuff, and you'd go in and sit and talk to people, and you'd want these expensive upgrades for your ship, and say, yeah, I want to buy it, and they'd have a little diagram where it's there. And if you had a mug of ale or a hamburger, you could pick it up and do a swap, and then say, oh no, I don't want it. And then walk away with the expensive device. Anyway, yes?
Just second order ignorance.
Oh yeah, not knowing what you don't know. That's at the heart of software engineering, and the more ambitious and complex your system, the more you will run into that. Yeah.
I think my least favorite thing is finding out that a really simple problem is a really difficult solution.
There are simple problems with very difficult solutions. There's actually some problems that don't have solutions. Yes?
I was gonna, kind of along the same line, say that a personal project, I want to make this game, and then it gets difficult, and then I want to jump ship to another idea that I have.
Oh, yeah.
And it repeats itself, and so I'm like, oh, I find that one that's going to be fun the whole way through.
And that actually is an extremely important point, is how hard it can be to see the project through all the way to the end. Because it does tend to get harder as you go in. And you're seeing less and less return for the hours you're putting in. That's actually one of the advantages of throwing out features, because you look at it and say, oh, okay, we're not going to do that. And suddenly it's like, hey, this is a lot easier now. All programmers are optimists. Adele Goldberg, one of the pioneers of object-oriented development, once said, only optimists build complex systems. In other words, if you really knew how hard it was going in, you probably wouldn't start. It's kind of like, oh yeah, this is a simple matter of programming. I'm going to dive in. All I have to do is this, this, and this, and that's how it gets started. We often assume each task will only take as long as it ought to take. That is a more profound statement than you might think at first. When you stop and think about the projects you voted on today. Now think about some aspect of that project that you may have thought about. Oh, I want it to do X. And you think, well, you know, doing X is really only going to require A, B, and C. There's a good chance that it's also going to require D, E, F, G, H, and I. But you don't see that yet. We're back to this, second order of ignorance. And this is why the schedule I did for Pages was wrong. It was a team with great programmers. I thought, oh, these projects will only take this long, or these aspects of the project will only take this long. And I was wrong on almost every single estimate. And then when you've got 8 to 10 people working on a software project with all these various aspects, each error tends to compound. We'll talk in a few weeks about PERT and Gantt charts and critical paths. probability that a given task will go well may be high, but a meaningful project comprises hundreds, if not thousands, of such tasks. In other words, we say, oh yeah, you know, we've got 100 things we're trying to get done, and we think they'll all go well, but you get 10 of them that drag out, and those 10 can impact your project significantly. Another truism, and I think this is from either Jerry Weinberg or Robert Glass. In a software project, it is very, very easy to lose a day on your schedule. It is almost impossible to gain a day, except by dropping features. It really is. It's like, oh, well, I'll just work a few extra hours this weekend, or you know, I'll program all night. We'll talk in Peopleware about how much you can really do over time. One of the readings you'll have from me in the Webster reading sets is an article I wrote called "Do Not Defer the Difficult." When we start programming, what do? Grab interface tools, grab some libraries, do a mock-up. Got a great interface. It all looks good, and it's like, hey, we're 90% of the way there. No, usually we're about 5% of the way there. The hardest problems we tend to push off. And they tend to all collect, and we run into them at the end of the project. And then we suddenly have half a dozen very hard problems that we're trying to solve at the same time. Any other ways in which we tend to be overly optimistic that we haven't talked about? Anyone? Yeah?
We can just always Google for the specific answer.
We can always Google for the specific answer, which is actually scarily true for a lot of stuff. But that said, yes, we think we Google it. Yeah.
Or we assume that there's already an API for it.
Yes.
The API is simple.
The API is there. The API is simple. The API is correctly documented. There's a difference between the shallow and the deep API. The shallow API is the actual, here are the method calls with the parameters that you have to put in there. The deep API says, and you have to call this one first, and then you have to call this one twice, but you can never call this third one, because you can call this third one and it'll undo what you did with the first one. A lot of APIs work that way, and if you don't know the deep API, you can chase your tail for a long time. Yes?
Code over here that I wrote earlier or recently, whatever, is correct. I've found that most of my debugging, where I spend a couple hours on something, is where code that I assumed I had written correctly and keep overlooking for a problem.
Yep. Yep, it's kind of like, well, I think that, and we're back, again, Maxim, you'll hear from me. The first 90% of the project takes 90% of the schedule. The last 10% of the project takes the other 90% of the schedule. And what it is often we've written code that's 90% done, and we think that last 10% is only going to take another 10% of effort. And again, it tends to be where all the hidden problems and gotchas tend to accumulate. Okay, Man-Month. The whole phrase is the idea, and this has actually become so universal now that people who have never even heard of Brooks know what a man, or know what the problem here is. Summed up best, and actually Jerry Weinberg used this analogy before Fred Brooks did. You can't use 9 women to produce a baby in 1 month. But managers think you can. Managers think, we'll just double the programming stuff and we'll get it done in half the time. They will add people, and Brooks' law from this chapter is adding people to a late project makes it later. Why? Because you're having to bring them up to speed and you're slowing down the people who are already working on it. Now, as we'll see when we read Accelerate, they talk about a way around Brooks' law, which is to come up ahead of time with an architecture where the elements are sufficiently decoupled that you can actually hire a group of people to work on one of the decoupled elements that's not affecting the rest of the project. But that said, there is a certain incompressibility to software projects. You know, adding people helps up to a certain extent, and after that, you're slowing yourself down, and you just can't compress it anymore. There's time that's just going to be spent, as per Armour, there's going to be time that is going to be spent in exploration and discovering your own ignorance. And the number of people you have doesn't help you with that. In fact, it can actually slow you down. There's going to be time spent in debugging that isn't helped by having extra people. Now, we already had someone talk about personal turnover. Was it over here? Who said about having people leave and take knowledge with them? You did. Talk about that for a second. What's the impact that you see from that?
So one of the big things is that I really liked what was said in the Orders of Ignorance about how it's a discovery process. So a lot of times when people leave, a lot of the knowledge of how the software works leaves, and then people spend time, like we talked about last class, with the misdirections,
They're
the
basically
unknowledge,
redoing
right?
the exploration.
Right, we redo the exploration because of all the footprints and things that were left there that aren't actually useful.
In the software industry, how many of you ever heard of the truck factor? The truck factor is basically how many people on your team can be hit and run over by a truck and you can still complete the project. You want to have a high truck factor. You don't want to be dependent upon just one person. But it often is. And this is why you need to share information. It's why you need to make sure that people, and what you'll find, in fact, have any of you had an experience? I recognize, you know, most have been doing internships. Some of you have jobs, real full-time jobs and so on. An internship isn't real full-time, you know. Have actually worked in jobs. Have you seen a situation where someone on the technical team is hoarding information? He or she has some specific expertise and is not letting anyone else know those secrets because that's job security. Has anyone, I saw a few hands. Anyone? This happens out in industry. You have people who want job security and or admiration or prestige, so they know how to do certain things and they are not training other people on the team as far as that information and how to share it. Component debugging and testing forces sequential constraints. Now, I actually wrestled for years with Brooks' comment that he says 50% of your schedule is testing. But the interesting thing, because no one schedules 50% of their project schedule for testing. But his observation is, whether you schedule or not, that's how much time you spend testing. And my observation is, yes, that's true. Because I see so many failed projects where this is exactly what's going on. They think they're going to make their deadline, and then they slip, and they slip, and they slip, and they're just not stabilizing because they keep trying to push it into production without doing sufficient testing. At Pages, when we closed on our venture funding, we hired Larry Spellhog, our permanent CEO. One of the things I told Larry is, I want to hire a director of quality. And Larry, bless his heart, said, why do you need that? Can't we just get some college students to come in and sort of pound on it for a few weeks before we release? I said, no, Larry, it doesn't work that way. And bless his heart, he actually listened to me, and we hired Dave Creek, who was an outstanding director of quality, ran a great QA team, and I think Larry came to appreciate why we did that relatively early in the project, why we had QA relatively early in the project. But, and we'll talk about this in subsequent lectures, QA is the red-headed stepchild of IT. It gets paid less, it gets less respect, it's a part of the schedule that gets cut. And it's why we ship so much crap software. Because people are not willing to invest in testing. When you read Accelerate, they will talk about continuous integration, continuous development, automated testing. That is the trend. But automated testing doesn't always work unless you have a stable set of automated tests that actually test what you need to test. So it's not a silver bullet. We'll talk about silver bullets.
Yeah, I was just going to ask how do you convince companies that QA is important and not a black hole? Because that's how they see it. They see it like money goes in, but money never comes out.
Well, it's hard. I can ask them, well, how much QA do you want on the airliner that you're going to fly on next week? It's kind of like, well, yeah, I really want them to do the safety checks. You know, I don't want the engine blowing up in mid-flight. You know, I don't want the airframe dissolving at 30,000 feet or whatever. But it's hard. This is a battle I've been fighting for decades, and it is a real problem. What else is hard about software? Gutless estimation. We'll talk. I won't go into this a lot here because we're going to talk about this repeatedly. Management often doesn't want to hear how long it's really going to take to get the project done. We have to have it done by this quarter. We've got to make our quarterly numbers. We've got to ship. You know, there's a passage in Henry IV where Hotspur says, no, where Lindauer says, I can call spirits from the vasty deep. And Hotspur replies, well, so can I, and so can any of the men. But will they come when you do call them? This is the attitude a lot of management has about QA. It's like, yeah, we'll just say we're going to ship, and it's going to ship, and we'll be fine. And it will end up being a disaster. How many of you have, and this by the way, how many of you have bought a game that was just released, and it turns out to be just buggy? It's all get out. Yeah. It's kind of like we have to have this out for the Christmas season. You know, Civ 4 back probably a decade ago now was a great disaster for that. They pushed it out for the Christmas season, and it was just buggy as all get out, and it was a tremendous backlash. I don't think they pushed that into Civ 4 earlier. Which one was it? The original Batman Arkham Asylum?
Oh, it was Arkham Knight.
Arkham Knight that just had problems up the wazoo. So you know this happens all the time. Software gets pushed out and it's buggy.
I have a question.
Yeah.
Do we have some market stats that we can say, hey, if you push it out early, you get returns and then lose reputation as well? So like, why don't we just wait?
Actually, you can make that case in model, but you'd be surprised how irrational some of the decisions are. I'm thinking of a case where I was an expert witness, where a insurance company was having an outside consulting firm re-engineer their systems. And it wasn't going as fast as the insurance company wanted, because the insurance company was responsible for the data migration, and the data migration is always a big pain because you're having to scrub the data and take it from the record format from the old systems and move it into the record format from the new systems and so on. But the CIO, or the CFO was basically the head of IT. CFO and the head of IT both had promised substantial bonuses if the new system went live on January 1st. So against the advice of the consulting firm, they pushed the systems live. And it was a complete disaster. They lost a tremendous amount of business. Sometimes they just don't care. And of course, what happens if you lose schedule? Slip deadlines or drop features. Okay. I'm going to postpone the talk on system architecture because we're already at 4 o'clock. So we'll push that off till next week, or 2 weeks. Next class is in 2 weeks. No class next week. By midnight, a week from Saturday, finalize your team membership. In other words, if you guys want to do any shifting, let me know. Update your wiki appropriately. Watch one podcast if you're choosing. That's on the. Did everyone know where the class website is? cs428.cs.byu.edu. Don't stand up yet. Update your team's wiki. Read chapters 7, 11, and 14 of Mythical Man-Month, and the Webster #1 readings, which is just 3 articles, all of which are short. And those are all on the class website. I will push out the information about what we currently have for team membership. I will ping the 2 people we don't have assigned for projects and see if they have any preferences. And you can always reach me on Slack. I hope everyone's on Slack. And that's it. Any other questions before I let y'all go? Thank you. That was a little longer than I wanted, but about as long as it gets.